The stream is ready. Hi everyone, I'm TigerHawk3, and today we're going to do something random. Not random. It's Python has a random module, and it's a module for being random. It's called random. That's the joke. Random. The kind of subtitle on this is generate pseudo-random numbers. That's an important distinction. Computers don't know how to be random. They don't do that. They are calculating machines. Your computer doesn't know how to be Invader Zim. Just random. That's a reference to a cartoon I don't think I ever actually watched. Maybe half an episode, because friends were like, "This is hilarious." It was okay, I think. But the idea was it's a whole bunch of random funny stuff. Random isn't actually funny. But, so computers don't know how to be random. They can do pseudo-random, which is the appearance of randomness to humans. Unpredictability. There's several paragraphs of introduction. One of the sentences is, however, being completely deterministic, it is not suitable for all purposes and is completely unsuitable for cryptographic purposes. What does deterministic mean? It means that given a starting point, you can determine exactly what it will do afterward. And if you're trying to make some kind of password program or security firewall something, you don't want it to be predictable, and then people can know exactly what it'll do. That's bad. For example, if you have if you're making one of these little keychain things with a periodically changing number that your customer uses to log in, that's called dual factor authentication. So they have something they have, and there's something they know. Something they know is their password, and something they have is this little keychain. And when they want to log into this secure system, they enter their password, and they look at the keychain, and they press like a button maybe or something, and it will show them a number that is valid for maybe a few seconds, 30 seconds, I don't know. And it's basically get a new password for each login is effectively what it is. Humans can't really do that, and the password comes from something else. Pretty good, except if your system relies on something that's deterministic, and someone figures out what determines it, they will know all the passwords for that little keychain forever. That's bad. One example of pseudo-random is the Star Trek Next Generation episode where Data finds his mother, which he's an android. So what that means is there was a scientist who was, for some time, I think, married to Dr. Noonien Soong, who was Data's creator, father, basically. And she helped create Data. So kind of his mom, pretty much. And at one point they, randomly met her. It was like, "Hi." And she's like, "Oh, Data, that's my kid." And they're like, "What?" So then, the story happened of whatever. And there's a spoiler here, but you should watch these episodes. Don't know if I should say the spoiler thing. How about I'll do the hand wavy. I will go like this when the spoiler is over. Okay? So there's spoiler now. Stop listening and watch for my hand waving. So Data is playing some orchestral piece, some classical music with his, mother. And he notices that she is playing it when they're performing it for others, she's playing it exactly like she did during their rehearsal. Exactly, precisely. And then he starts being kind of suspect of what's going on. And then he notices that she blinks in Fourier pattern? Bezier? I don't remember. But her blinking is not random. Humans blinking is not random either. It's intended to prevent our eyes from drying out, so it's whenever that needs to happen. But it was pseudorandom, and it was deterministic, and he found the factor that determined when she would blink, and he's like, these blinks are calculated by a computer. She's an android. So that's pseudorandom, and the spoiler is finished, so you can come back and yeah, it's all good. Go watch those episodes, all of them, all of Star Trek. There's only, hundreds and hundreds of hours, but it's good. It's all good. Even the parts about the ventricular trajectory and Spock's brain and lizard babies, all of it. It's all good. You should watch it. Anyway, so there's your warning about don't use this module for security purposes. Cryptography is hard. Bookkeeping functions, I don't know if we'll go over those. I'll mention them briefly. There's a random.seed that starts the random number generator, and then you can get a series of random numbers based on this starting point. Random.getState. If the argument to random.seed is omitted or none, the current system time is used. So that's kind of a random-ish factor. If randomness sources are provided by the operating system, they are used instead of the system time. You can provide an int and have that be used directly. Or a string, or a bytes object, or a byte array object. GetState. Return an object capturing the current internal state of the generator. I don't know what that means, and it doesn't really matter. It's a bookkeeping function. SetState. So you can see that. A setter and a getter, basically. GetRandBits. Returns a Python integer with k random bits. Whatever. Here's the fun part. Bunch of functions. Good stuff. Let's do that. Random.randRange with an argument. How about 4? Observe that it keeps giving me random numbers including 0, 1, 2, and 3. RandRange is basically similar to Python's range object, in that if you send it one argument, it will choose from 0 up until that argument exclusive. And you can also do this. 1, 25, and 4. A start, stop, and step, if you want. So that will give us 1, let's actually do 10. So this can be 1, 11, or 21. See? 1, 11, 21, that's all we get. So that's cool. Random.randInt. And this is similar to randRange. Gives you a random integer between A and B, and this one is inclusive. The documentation just says alias for randRange A nb plus 1. That's all it is. And you can omit the step argument just like you can with range, and it will go from 1 to 25 with a default step of 1. 3 and 9. See, it does that. And there's 9. See, inclusive. What else have we got? This is an important one. Let's say we have a list of hello world, how are you? Okay. Oops. Forgot the equal sign. Sorry, interpreter, my bad. So sometimes when someone learns about the random module in school, for example, they'll learn with a random number guessing program. The computer picks a random number and you have to guess it, and maybe it'll just tell you whether you're right or wrong, or it'll tell you whether you're too high or too low, and that helps teach branch things about branching. And then maybe someone wants to pick something out of a list like this one, and so they say, I will find the length of the list. They'll do this. Let's start from here. I'm going to find the length of the list, and I will pick a random number. They probably just learned about randint to get a random integer, right? They have to subtract 1 because they don't want that. That's not an index because that's what we're going to use this for. Then we're going to do L, and we're going to index it. See? Similar thing. But picking an element at random, at pseudorandom, is pretty popular. Something people want to do kind of a lot. So here's what we will do. There's a way to do that, and here we are. Here it is. Something to keep in mind. That doesn't work because the way that the random.choice function works is it moves things around with indexing. You can't index a set, so whatever you're doing has to support indexing, like a tuple or a list or a string. Random.choice, hello. The documentation for random.choice says return a random element from the non-empty sequence. And this is a list of functions for sequences. A set is not a sequence. It's a collection. A sequence proceeds from one element to the other in an ordered fashion. So a list is a sequence, a string is a sequence, because if you have the string hello, it will always be in that order. Things aren't gonna move around depending on your implementation, while that can happen with sets and dictionaries, which are hash tables, not ordered. Arbitrarily ordered. Same for shuffle. Random.shuffle. And now, note how this doesn't work. Because the way this works is taking various elements of the sequence you pass it and moving them around in place. So I can also do this with the same error, because you can't reassign things in a tuple. Tuple object does not support item assignment. and it has to. Good error messages. This is telling you it needs to be something that supports item assignment, and these types do not. Let's look at L, and now let's do random.shuffle L. Now let's look at L again, and it is shuffled. Amazing. Now, let's say you want to pick random items from this list. This is interesting. Functions for sequences, and then it says random.sample works on a sequence or set. So, okay then. The second sentence of the documentation says, used for random sampling without replacement. This is a concept in statistics where the common example is you have a bag of marbles. What are the chances that out of all the black and white marbles, you will pick one and get a black marble? I don't know. And what if you pick one again? Let's say the bag has 10 black marbles and 10 white marbles. What's the chance that you will get one of a particular color? 50-50. You set that one on the table next to you, and you pick another one. What are the chances then? They're not 50-50. So that's without replacement. Random.sample is such a thing. If you have all of these elements, and you do random.sample, I want 2 of them, for example, for X sample. No. Oop, forgot to tell it what I wanted to pick from. R and hello. And what's the length of L5? I can get 5. And notice it's not like hello 4 times and then R or something. That's because it's without replacement. I wonder what happens if we exceed it. Does it say in the documentation? If the sample size is larger than the population size, a value error is raised. There we are. Sample larger than population. That's basically take 20 marbles out of the bag with 20 marbles. What's the next marble going to be? There are no more marbles. At that point, you have lost all your marbles. Good times. Random.sample. This allows... the resulting list is in selection order so that all subslices will also be valid random samples. Okay. This allows raffle winners, the sample, to be partitioned into grand prize and second place winners, the subslices. Members of the population need not be hashable or unique. That's cool. If the population contains repeats, then each occurrence is a possible selection in the sample. If I had 1, 1, 1, 2, 3, and I got a sample of 2 of them, it could be 1 and 1. Let's see what happens with this, right? Oh, forgot to change that. We can do it because it can work on a set. So that's cool. Here's something most people have heard of or used. The following functions generate specific real-valued distributions. Function parameters are named after the corresponding variables in the distributions equation, as used in common mathematical practice. Most of these equations can be found in any statistics text. Great. Random.random returns a number in the range. I will paste this in. Notice they have a square bracket here and a parentheses here. That means it could be 0, and it could be anything up to and not including 1.0. Random.uniform return a random floating point number n such that a less equal n less equal b for a less equal b and b less equal And for seriously? This if A is less than B, and the otherwise for, okay. So basically, return a random number, a floating point number, between these two numbers. And you can do this, and it doesn't care which direction you have. The endpoint value b may or may not be included in the range depending on floating point rounding in the equation. A plus b minus a times random. This is what it's doing. Here's the implementation. So we have the first number plus the difference between the other number and this one. So we could have 3 plus 4 minus 3 times random. So that's 3 plus 1 times a random, which is between 0 and 1. So it's going to be 3 plus somewhere between 0 and 1, meaning between 3 and 4. How about 33 and 4? 33 plus 4 minus 33, so that's a negative number, times random. So it's 33 minus some stuff, which results in being between 4 and 33. And this is random.random, I should say. Because they assume from random import star. Don't do that, or you will pollute the namespace. Random.triangular, what? Return a random floating point number n such that it's between the low and high, and with the specified mode between those bounds. Low and high default to 0 and 1. The mode argument defaults to the midpoint between the bounds, giving a symmetric distribution. Oh. Okay. Let's see if I understood that. Random.triangular. Let's say, let's just give it specific 0 and 1 with the mode being 0.5. I guess this is the default. So that's just a whole bunch of random numbers. Let's see what happens when we give it 0.9. So this is a weight, I guess. So this is more likely to give us largish numbers than smaller ones. No? Let's do the following. Map int and something, and I'm gonna do random.triangular. Let's say 1 and 10 skewed towards 8. Oh. This, I know. For something in range 10. 1, 2, 3, 4, 3, 4, 3, 2, something's wrong. I'm counting parentheses now, by the way. 1, 2, 3, 4, 3, 4, 3, 2. So I have random.triangular this for in range 10. That's that, and now I'm going to close the map and print. Fantastic. So it looks like it was more likely to give me high numbers. Does the mode need to be between them? Can I do that? I can't. Notice how it's all kind of high numbers? Oh, I thought it would be triangular. I guess you can totally mess with the... That's interesting. So let me read you the documentation on this. Return a random floating point number n such that low less than or equal to n less than or equal to high, and with the specified mode between those bounds. The low and high bounds default to 0 and 1. The mode argument defaults to the midpoint between the bounds, giving a symmetric distribution. So apparently, if your mode is outside of the range of the low and high bounds, you can get an n that does not satisfy this low less than or equal to n less than or equal to high, because -2 is definitely less than 1. Let's see what it says about random.triangular. That's it. It gives me a Wikipedia link. Classy Python. Classy. Continuous distribution bounded by given lower and upper limits and having a given mode value in between. So it's not actually bounded by lower and upper limits. Not sure. That's interesting. I would have thought they would include a note of what happens if the mode is not within the bounds. Maybe that's something I should look into. Why does it do that? N out of bounds when mode out of bounds. I suppose it's, I mean, I get it. I get why it would do that, but it seems wrong. It seems, it's undocumented behavior by definition, because it's not in the documentation. Random.beta variate. Alpha and beta. This is a beta distribution. Conditions on the parameters are alpha greater than 0 and beta greater than 0. Return values range between 0 and 1. I don't know what that is. About 0. Oh no, it has to be greater. So 1 and 2. I don't know what this means. I don't know. That's how you do a beta variate distribution in Python. Hopefully you know what that is. Random.expovariate exponential distribution. And they call the argument this, not lambda. I mean, it is a lambda, but they can't actually call it that because that's a reserved word in the Python language. I thought maybe they could call it underscore lambda. That would be good. That argument is 1.0 divided by the desired mean. It should be non-zero. Returned values range from 0 to positive infinity if lambda is positive, and from negative infinity to 0 if it's negative. I don't know what that means in particular. Let's see if I can give it something that produces a normal looking result. I won't understand it, but at least maybe I can use it. It should be 1.0 divided by the desired mean. How about a mean of 0.5, which is between 1 and 1.5, I mean, which is between 1 and 2, and 1 divided by 1.5 is 2/3. I got a number. Yay. It's above 2. Is that bad? I have... Oh, it's 4 now. I have no idea. Gamma variate. A gamma distribution. Not the gamma function. I was wondering if it would be that. Do you mean the gamma function? I don't know what that is. Conditions on the parameters are alpha greater than 0 and beta greater than 0. Oh, the probability distribution function is probability distribution function of x is equal to this divided by, put this in this just in case, that. Oh, it's long. Okay, divided by, actually, no, that was unnecessary. I'll just make it a string. And then, print star this dot split on space slash space and separator equals a new line. There. Oh, there's more. There's one right here. Let's change that to be 2 spaces. Great. So we have x to the alpha minus 1 times, I think this was e to the number, times e raised to the power of negative x over beta, all divided by math.gamma alpha times beta to the alpha. That's great. Let's do something else. Random.Gauss with arguments mu and sigma. That's great. Gaussian distribution. Mu is the mean and sigma is the standard deviation. This is slightly faster than the normal variate function defined below. That's fantastic. Random.log norm variate with mu and sigma. Log normal distribution. Great. Random.normal variate. Normal distribution. I've heard of that. How do I even pronounce that? To the Google. Von Mises? Von Mises, after this person. So that's what that is. Mu is the mean angle, expressed in radians between 0 and 2 pi. That's a circle, a full circle. And kappa is the concentration parameter, which must, this doesn't matter. I don't care. There's also random.Pareto variate, random.Weibull variate, and that's not Weeble as in the little toys that stand up and then you push them over and they come back up. No. I mean, probably this guy, some mathematician. Guy or girl, I don't know. Could look that up. Weeble. And who is that? Named after Swedish mathematician Walody Weibull. Okay. Named after someone with, after this person. So, I don't really know how to pronounce that properly. Sorry. Alternative generator. A class of random.systemRandom with a seed. That's great. We're not going to use that. If you want to do your own stuff, I wouldn't recommend it. So the basic useful things that you should know are rand range. That's a number in a certain range, similar to Python's range object. Rand int returns a random integer. Not really necessary if you have rand range, because it does like the same thing. It's an alias for rand range of a and b plus 1. Random.choice to let you pick from a pick a random element from a tuple, string, list, that sort of thing. Any sequence that's needs to be indexable. Random.shuffle to shuffle a mutable sequence in place. Needs to support item assignment, meaning you need to be able to change it, so a tuple won't work. Random.sample to get a few items without replacement. If you want to do with replacement, you can do random.choice a bunch of times. Or even just random.sample with a sample quantity of 1. That works. But if you want without replacement, you can also use this to basically provide a shuffled list out of a set. Because you can't shuffle a list. They are not indexable. They don't support item assignment. And their ordering is arbitrary. It's not already random. If you have S equals a set out of L, let's look at S. Let's look at S again. Notice how it's in the same order. It's arbitrary, not random. And the general way to get this is not a way to get a random element from a set. It's a way to just get an element. Just get something. Don't care what. Is call next on it. On the iter. Make an iterator out of it and get something. Notice how it's the same one every time? It's because it's not random. It's arbitrarily ordered. It picked an order that wasn't based on something you chose. You don't necessarily know what it's going to be depending on which version of Python you're using. And by version, I mean it could be CPython, but implementation. Someone else's Python thing. It could be sculpt.org, which is a kind of an incomplete implementation of Python. I think it's like written in JavaScript or something, and it's Python 2, and there's a lot of missing stuff. I found it at one point. I'm like, that's cool, but then it's like this isn't really usable for anything. So you can do a random.sample with a sample size equal to the population number. If you want to basically randomize a string, random, let's do nothing dot join random dot sample hello and 5 and close the join. There we go. Isn't that neat? So we can sort of shuffle it, but we can't actually use shuffle because that works in place a different way, and samples just kind of looks at your collection and picks things out of it and makes a new list. Random.random, something between 0 and 1, period. Random.uniform, similar to random.random, only you can pick the start and end point. Random.triangular, which I will have to look into. to let you kind of skew the random results toward one way or the other. You can use that in a game program if you want. If you want to say it's random whether your crafting thing will succeed, and you have, you have to roll a 6 on this die, but it's not using random.randrange, it's using random.triangular and skewing towards one end. You can totally do that. It's mean, but you can do it. Betavariate, expovariate, no. So the big things are, I would say, random, uniform, sample, shuffle, and choice. And maybe randrange. You should try to maybe stay away from randint and randrange if you're using them, unless you actually want a number. You might be doing something wrong. Like I mentioned earlier, if you're using it as an index for a set, like instead of I want a random item from this, you're saying, well, I will pick a random number and use it to index the list, and that will get me a random item. No, don't do that. Just use choice, and it will get a random item. It will do what you actually wanted. So I'd say choice, shuffle, and sample are probably the big ones. Good stuff. That's the stream for today. Tomorrow, I found solitaire, and by found, I mean my computer does not let me access the Windows Store. It gives me some error that it just doesn't work. Apparently it's a thing that happens sometimes, and you have to mess with whether you're using a proxy. I am not. Some other stuff. If you're using a Windows Live account, log on locally or the reverse or something. And I don't care. I don't want to. But and you can get these games from Windows 7 if you copy some things and go into edit the executables with a hex editor, because it has a version check, etc. But if you have a computer with XP, and I have a netbook that runs XP, you can just get a DLL that it needs, cards.dll, and then all the little executables, just copy them and move them to another computer with the flash drive or something, and you're done, and it runs. That's it. So I have classic Minesweeper, Solitaire, Spider Solitaire, and Free Cell, and Hearts on my computer, and 3D Pinball, the Space Cadet. That's it. Funny story about pinball. This is from Raymond Chen's blog. He works at Microsoft, and he works on the Windows kernel. Very fancy things. So at one point he noticed that pinball was kind of making the computer unusable. Like he wanted to print something while playing pinball and it wouldn't do it. And he investigated and found out that it was just rendering frames as fast as it could. Most games do that. If you have like League of Legends, for example, and your computer can handle it, you may get like 200 or 300 frames a second. It'll do what it can. But we really don't need 90 bajillion frames a second for pinball that's made for ancient computers. So he actually fixed it to make it sleep for 1/60th of a second. Basically limited the frames to 60 frames a second. And so it went from using all of your CPU to using pretty much none of it. So now you can play pinball while you're doing other stuff. Except if you want it as a native 64-bit application, because they didn't want to do that. He said that they tried to port it to 64-bit, but they actually got that program from some other third-party company and just like licensed it out, and they couldn't figure out how to port it over. It was too messy. So they're like, I don't know. But the 32-bit version works fine. And I have it now. So maybe Solitaire tomorrow? I don't know. It's not quite as fast-paced as Minesweeper. But game of some sort. I don't know which one, but it'll be something. So thank you for joining me today, and I hope you join me tomorrow. And that's the stream. Thanks, and have a good one.